English, if you didn't know this. And I have the pleasure of welcoming our next keynote speaker, Jonathon. I actually asked from Jonathon, are you from UK, or are you from Wales, or Scotland, or Ireland, and he said that well, he's from UK and he spends as little time as possible in UK. He's a resident of New Zealand, lived in Australia, lived in US, quite many places. I think the most exciting thing when I was reading about your bio was that you've been working with the UK government with the Brexit 2 years. I think we might have a question about that in a questions part if you get to the Q&A. But before that, I think it's now time to start to talk about intelligent operations, AIOps, and what actually does that mean. Jonathon, please, welcome. Thank you.
Hi everyone. From that quick introduction, I guess I'm the only one holding you between the drinks in 45 minutes, so I will try and peak as quickly as possible with this, with limited Brexit jokes. So yes, it's an absolute honour to be here in Helsinki, and just in case, because I cut quite a few of the slides out because of the time, and I really wanted to focus on delivering some of the core messages for each slide. I've actually put the deck up, the full deck, available on my slideshare at the bottom. Please check that out. It'll have a lot more detail, and some of these slides I will go through quite quickly. You also notice in the back I've got my TED Talk. So my TED Talk, which I did not last year, the year before, was around cognitive learning. So it's around this feedback from operations back into the thinking and design process. So hopefully that will help align nicely with the core messaging I want to share with you around what we've been doing in the UK government for the last 2 years, and also a couple of the AI companies that I've been working both in Oxford in the UK and also in Silicon Valley. So people kind of ask me about AIOps quite a lot more than they used to, and I nearly did include seeing the Google trend of how it's become such a popular term. Especially now that Gartner and Forrester have started coining these kind of terms. So this is some of the list of some of the terms that have been kind of floating around for the last few years. And I'm just going to focus on that intelligent operations component. But before I start, I added in a quick slide just over the lunch break since my journey here around in Finland. And it was really interesting because I remember the DevOps movement many years ago, and really what DevOps was trying to achieve was the transparency between development and operations. And one of the core messages which kind of DevOps was trying to say was, if you do it more, if it hurts, you do it more, but you get better at it. And I think there's still quite a lot of organizations that still have trouble achieving DevOps, or even Agile, or some of the other methodologies. And I think it's because of that reluctance to fail fast and learn rapidly. So as I've tried to fail fast quickly on this one of your electric scooters, the core message was, definitely for AIOps, is that celebrating failure is something we've got to change the culture. So if you're only going to take one message out of this, that is it. That actually DevOps was, it hurts, let's do it more often. AIOps is really saying, celebrate failure, not shy failure away, which is a really difficult cultural thing to happen. And that's really where AIOps will help you on that journey. And I don't know if you've ever seen this gentleman who's the conductor of the Boston Orchestra. He always says, whenever there's a mistake, he says, how fascinating. And that's, to me, exactly what we've been doing for Brexit, for the UK government, is we've been looking at these huge, complex ecosystems that power everything from our Department of Work and Pensions to Her Majesty's Customs and Revenue. And every time we find these incredibly interesting problems, I'd like to say we said how fascinating, and not just try to work out how quickly we could make the problem go away. So celebrate failure. Okay, so I pulled Gartner's definition / diagram of what they believe AIOps is. And they're talking about, a bit like the three-pronged diagram that I showed on my TED talk, it's about this observe, engage, and act. So that aligns nicely with this kind of thinking, doing, and learning aspect of things. So for those guys who aren't familiar with AI and machine learning, this is the best quote that I've found so far. And unfortunately, the reason why is because a lot of the organizations that I work with, you wouldn't believe how much of their AI is just slideware, which is incredibly upsetting. A couple of the companies I work for literally have just changed their domain to .ai and not added in any AI whatsoever. And I think this is a bit of a concern. And I had a guy flying over from the Pentagon last month from a company called Calypso AI, which helped the White House do their AI defense platform. So what they're doing is trying to prevent AI from going out of control. And there's a slide with Davy's stuff on the back. And he said the amount of organizations that he goes to, and he says, that isn't AI, that's just a whole stack of if statements. There's no value, we can't protect from that because there isn't anything to protect. Whereas actually some other organizations that aren't as noisy about their AI are doing some really interesting work. So I'm going to try and share some of those stories. And there's a few more quotes there, which I'm not going to go through, but it's interesting the adoption rates of these things. So people talk about how many organizations have actually adopted AIOps. The 4% seems like a sensible number from what I'm seeing in the industry. But I do see people investing in this area. I know we've got Dynatrace in the hallway, which I will be talking about in some of my slides, who build AI onto their platform to help kind of do this self-healing and preventative approach to operations. And I recommend checking that out. And I will talk about it through one of the case studies which I'm going to share with you from real-world experience. But I can take it back a little bit because some of these core principles aren't new. And as we know, we're in this kind of fourth industrial revolution, which is this kind of AI being the future of everything that we do. But it isn't new. Where I live in the UK, there's a place called Bletchley Park. I don't know if anyone's heard of Bletchley Park here. But it's where Alan Turing was based during the war, and the Enigma code. I'm guessing a few people have seen the movie, maybe? One guy, that's great. So Turing, this was back, I think, in 1950, is when he started publishing his first materials, which are there in the background, which were stored in Bletchley Park, around the singularity. A couple of the slides around the singularity there. It's quite interesting because of this isn't new. And if on the left-hand side, I don't know if anyone notices that, but that's 1939, and that's when Hewlett and Packard, when I was based down in Santa Clara, used to work in their garage in the first ever, what it was a calculator back then, but they started building the microprocessors back in 1939. And now, however many years later, they're now morphed into microphones, which are outside today. So it just shows you their approach of getting it in a garage and literally doing this whole design, build, test, build, test, build, test. You could say it's potentially agile back in 1930s, but they were doing Mark 1, Mark 2, Mark 3. What could they get out as quickly as possible as a product? And we may have called this waterfall V model in the past, but this was kind of this ability to kind of learn from the end component. You got it out in the marketplace, but it wasn't influencing your design. It was either failing or working. So I think things have changed, and partly what I tried to focus on for my TED talk is this: how do we feed back? And what I think the component which we're talking about today is this flow back from learn to think. And so this is where AIOps comes into play. And this segment is around helping predictions to change the underlying designs. So a lot of what I've done with people like Apple in the past is building models to help them understand the complexity of their systems and help them with the build and test, this creation component, which is always a human element. And then operational side of things hits in this kind of learning aspect. So this is where, bringing in an APN stack will give you the insight that you need. And then you've got this level of prediction using machine learning and predictive analytics to actually give you things happening before they actually happen. So it's about making this feedback cycle a lot quicker. So I'm going to break into each one of these components and I'm going to give you a little bit of a use case for each one, just so you've got an idea of where you may apply this in what you do. So I'm going to start with the design and modelling. And I noticed one of the workshops today was around the value mapping, value proposition. And I think this is a good place to start because I guess when we were looking at big data, the big problem with big data was, well, what was the questions we wanted to ask it? And this is the same problem which I think we've now got from an AI perspective is, well, what is the question we're trying to actually fix? What are we trying to take advantage of AI? So, a lot of the organizations that I talk to who are attempting AI bring in a whole stack of data scientists who are very theory-based, fresh out of university, incredibly talented, but they don't understand the domain, they don't understand the expertise around that area. So if that is something like finance, which is obviously a fantastic candidate for something like AI, because accountancy and finance have got a lot of rules which can be expressed by rules or whatever kind of rules engine you want to use. And they're very process orientated. They're very good for kind of AI. But what I've noticed is it's not just having the domain expertise, it's not just having the data scientists, it's actually more around having the data engineers, the people who can get the data into a format that allows them to start understanding the value of what they found. Because 90% of this isn't really adding any value if there isn't an opportunity to change how the worker who would have done this manually does it using this tool and uses the insight. So a lot of what I've seen is augmented intelligence, which is where people have identified roles within an organisation and then looked at how they can enhance their workers. So this AI augmentation, which they're saying is a huge amount of opportunity in the marketplace, is applying cognitive technologies to actually reduce work. We could call it RPA, but we could also look at this as things like Amazon Mechanical Turk. So for one of my customers, which I'm going to give you a demo for, is they're using computer vision to recognize products. So they're looking at identifying trousers, shoes, t-shirts. So sometimes, as you'd expect, the ML or if they're using something like TensorFlow, isn't going to find the answer to the problem, and it's going to potentially have a misclarification. So therefore, they augment that using humans. But based on human intelligence, there's obviously certain skills. So if you're in the fashion industry and you're able to identify a picture, then you can augment their AI, which means as it's learning through, it's not generating 90% clarification rate. You can then augment that out. And even better, you can use Amazon's Enter platform to point data sets or images, and then it will use enterprise crowd, to actually allow those work items to be solved. So that augments the AI platform instead of just not dealing well with that last 10%. So when I did my TED talk, it was quite interesting because it was the same time Sophia was made the first. She was given a passport and first recognised in Israel as the first robot that could have her own identity. Has anyone ever seen anything from Sophia? Yeah, so this really fascinating stuff that she's, the best one I've seen in recently is where she's critiquing Aldi's AI platform as it drives down the motorway, and she sat there going, Why is it not indicating? Why is it not flashing to let people in? You know, I could do better than this. You know, why is your AI so primitive? And that's quite interesting because there is a lot of AIs that teach other AIs how to actually work. So this suddenly starts getting incredibly complex. She did retweet and send me a message, which was quite interesting. That she noticed that I was in her presentation, and she was asking if I'd solved this problem. And I said no. So she was kind of, but it's interesting that she's actually there and she's thinking about the problem space, and she's thinking about how she would explore it. So part of that value proposition workshop we took, some of you guys might have taken today, you know, there's this thinking aspect where you're observing and you're researching it to create the background information to create an experiment and a hypothesis. A lot of the organisations that I've been trying to help with the creation component are quite quick to bring any idea to the table and push it through any sort of development lifecycle without really proving the hypothesis first. Whereas actually, for a lot of these projects, you can prove whether or not this is going to add value very quickly without ever writing any code. And I think that's when it becomes very interesting as a proposition that if you can't prove the value it's going to add to your end customer, then why would you start it in any kind of development lifecycle? So this ability to do the experiment and a hypothesis very quickly and model the problem space or the desired outcomes which you're expecting is incredibly useful. So that's one approach. My friend Ray Arel, who's based out in Portland, he worked at Intel all his life, and out of the back of that, he built this. He was the global head of Agile. He built this model around dimensions that he looks at when he's looking at a particular idea or an area, and the focus around that. Is this kind of understanding the relationship between business, technology, and usage. And you know, breaking into something like usage, you've got things like goals, needs and wants, human values, satisfaction. And by understanding and exploring these different components is the way that they flush out at Intel an idea or something to move it into the next round of development. So this is the thinking component that I mentioned first. And these are potential frameworks that you can use. There is a video there at the bottom, which is a full hour of Ray talking about solution thinking and how you can potentially apply that within your organisation. And also things like cognitive bias, which I'm sure other people have talked about, so I won't go into in too much detail. So the next one is around build and test, something that I think we're probably all very familiar with. And I think when we go through these normal life cycles, what we're trying to do is understand, well, what is it that we're trying to build? And unfortunately, one of the temptations which I've seen in the industry is for people to build something over buy. So there's a large organisation which do food shopping in the UK, and whenever there's something new, they go straight at it, they invest huge amounts of money, and they build their own AI platform. Now, the move towards AI as a platform, which is you building an in-house, you know your data best, let's build some AI because it's exciting, versus AI as a service, which is looking at how you consume AI. And that could be from people like your Microsoft Cognitive Services, it could be from IBM Watson, but actually, they've already advanced so far. Why would you reinvent the wheel? Why would you try to build that? Build your own product when your main driver for your customers is food produce. It's not about building an AI in-house capability. So I hope we're going to start seeing this move over the next couple of years for more AI as a service over AI as a platform hosted internally. And it seems that Gartner have kind of picked that up. I've broken this down into a trifecta. And you know, if we were here 5 years ago, we'd be probably talking about intelligent process automation or RPA, and about the huge opportunity RPA has. And organisations and acquisitions like UiPath have taught us straight away just the value of where we can target RPA. Insight-driven analytics is something we've all been dealt with in the industry for a very long time as well, trying to understand where the value of that is. And then enterprise AI. Now this is an interesting one because what I've been doing with my customers is enterprise AI platforms. It's around scaling AI in an organisation. It's not about a couple of different siloed initiatives that work well, a bit like scaled agile from something like SAFe or DAO or less. It's the same approach. It's how do you make AI stick across the entire organisation, not just in little silos. And as we say, humans are the main component to this. And I'm taking this from Ray. Ray does a lot of research into, he runs a research company based out in Silicon Valley. And I really like this slide because he's kind of saying, and I dropped in a couple of the sessions which were kind of saying that the myth associated with AI and what AI can't do. And I was trying to hopefully express that this build and test component is the creativity, is the magic sauce which we all bring together. When Gartner talked about it, that AI is going to bring 1 billion jobs a year extra for the ones that it loses, this is where this opportunity happens. You know, these creativity and physical presence and complexity is pretty much the boundary of where you potentially don't want to get involved. Whereas some of the repetitive stuff, the stuff we've been talking about from RPA for a very long time, does seem to tend its direction towards AI a bit more. Now I'm going to share this methodology. So on the previous slide, I hosted an enterprise AI conference in the UK last year, and I brought a whole stack of data scientists together, and we were trying to work out, is there a methodology that we need to apply to actually help us quantify the value of doing AI in the first place? So we came up with this approach called gated AI. So very similar to what you would get in other methodologies. It's around understanding the goal, understanding the accuracy that you're expecting the AI to do, the amount of time is required to actually do it, the ecosystem and the complexity around that, and then of course data engineering. You know, the data component is obviously the most difficult of the lot. So I'm going to give you a bit of a sample of this. And I'll start with, I did this book called Digital Quality. The example which was in the book was around autonomous vehicles. And I guess most of you have seen the Tesla 3, which is the new baby electric car. And one of the features that appeared a couple of weeks ago is this summon mode. So the summon mode allows the autopilot to kick in and drive your car from wherever it is to your house, which is great. Apart from, you know, there's obviously lots of challenges around this, and I think part of that is, you know, how do you test and build this system to be able to actually deal with that and the responsibility. And we've seen all sorts of interesting things happen. People jumping in front of the cars. Someone got run over by a Tesla quite recently. And I've got on the left-hand side a picture of a hire car that I borrowed quite recently. And the first thing I did was register it with my with the connected app. And then what I did is I actually connected it to my Alexa, who would then say, I could just say in the morning, turn the car on, lock the doors. And you know, we've started getting these kind of edge cases where people are shouting through letterboxes into people's homes, saying, Alexa, transfer my bank account, you know, Alexa, unlock the car. You know, there's this certain security concerns around these AI. And also, what we were trying to do. Now, this is a bit of an edge case. The actual goal I'm going to be talking about here is the one around the fashion, because it's from a fashion company that I'm working with in the UK on AI solutions. So we had a bit of a challenge. We had a challenge which was large organisations like, I guess you've seen Superdry's in Finland, right? So they've got a huge amount of products. And Julian, who was the CEO, now back in the board, the CEO, was kind of said, okay, I want to be able to get my products out there very quickly. So as you'd expect, at the moment, if they want to list their products onto any kind of marketplace, so let's give it Google Marketplace or Instagram or some other platform that somebody starts wanting to buy and sell. So Instagram allows you to see a product in a picture and then click on it. It's very much like Google Lens did, so you could actually take a photo of a car and see what that car would look like on your driveway or all those kind of areas. There's all sorts of ways of buying products. So on the right-hand side, we've got Microsoft's cognitive platform, which literally will identify handbags in photos. And then we built our own, so this is TensorFlow running in the background, but we built our own platform to recognize and train on photos. Now, the problem with this is you can over-engineer, or you can actually get to the point where you're actually spending much more compute time, and you're also spending a lot more energy to identify, get a better clarification rate. So this was kind of our goal. Our data scientists wanted to get to the 80% plus, which is kind of the industry standard, that once you get to 80%, maybe you shouldn't be trying, that extra 10% is quite hard to do. But there's actually a platform created by Google called Kaggle, which is kind of Swarm, which is this ability where you can put a data science problem out there and everyone competes against it for a $10,000 prize. So actually there's a whole stack of community out there who will try and take each other on by creating an algo or an algorithm that will solve your particular problem. There's a great example there with the Titanic. It works out which people survived and which people didn't, and the highest scores around that 90% accuracy rate of did this person survive, they were in first class, didn't have any children, etc., etc. So lots of different factors to go there. So accuracy was an easy one to quite easily miss. So part of these, a bit like if you were going to use something like behavior-driven development or specification by example, like Goko, the book written by Goko. This is a quick way of saying, what's the goal? We want to be able to recognise women's fashion. What's the accuracy? It has to be over 70%, because we're going to have to augment the rest of that. And if they've got 10,000 products a day, then that's going to take a lot of time for some either mechanical turk to come back or augment it with internal resources, which is not what they want to do, but it's what they were doing before they implemented AI. So on the left-hand side is a picture of their platform, where it automatically detects that these are trousers, and it also puts them in the different, that they're active trousers, denim, with pockets, all from the picture is recognised automatically by computer vision. So they do that very quickly, and the ones that it can't recognise are then augmented. So how do we do this? Well, the next one's around time, and as I kind of hinted a little bit about it, we were able to kind of get the numbers up to over 75%. The problem was it took a huge amount of time, compute time, to actually be able to get to that point. Whereas what we wanted to do, or what the customer wanted to be able to do, is they wanted to be able to recognise 10,000 images a day. So they wanted to be able to put up an entire summer's clothing range up, and it to be able to be put onto the marketplace within a day. And obviously, as growth happened, we'd have to be able to scale up this platform. So even though it's getting better results, and this is the temptation, if you hadn't used gated as the kind of approach, you'd have gone, well, we'll go for the one with the higher accuracy. But then it would have cost you a lot more money in compute time, but also it would have been a huge limiter going forwards of how much you can scale this AI platform or AI as a service. I've also, there's a quick mention in here of Destiny. So Destiny, for people who've not used, who are not in the area, Destiny is an Amazon standard for universal AI to be kind of defined as machine learning, which is very useful because obviously there's lots of different competing platforms that are around there at the moment. So finally, we're kind of getting up to the kind of the ecosystem. So when I did this for the UK government, which you can see on the right side just what that mess looked like. Thanks, Diamond Trace, for that. Part of it is we have to apply heuristics, or what we would have traditionally called in the ITOM kind of world, operations world, is these enhanced transformer load. Now, you may think, well, ETL has been around for ages. Well, it's the same kind of problems that we've been dealing with for ages. I remember doing this for Apple, based out in Sunnyvale, and they were, the question which Tim had was, okay, how do I get what people are buying on the App Store quicker than 24 hours? And it's like, well, you're the biggest ESAP company on the planet. You've got something in the region of 200,000 transactions globally happening a second. You have to wait for your overnight batch to get any intel out of it. So that Tim's going, but do you know how much that cost me in billions of lost revenue when I can't get what's trending onto the front page? And we were like, well, your fundamental architecture did not support us giving the ability to actually go into do a data lake or something where you could actually start harvesting that data. Of course, he could have probably gone SAP HANA or whatever, but I don't think that's on his list of to-do things. But yeah, the ability to understand the ecosystem and where you collect data from is incredibly useful. On the left-hand side, I've got a spider that we used for Superdry, which was harvested their website. So part of training, you've got two choices. You've got training a system by using Bing image search or something to come back and show you 500 pictures of trousers. Or you can go onto their site, look for trousers, and then learn against their products. So that way you've got more enrichment there. You've got, their colour scheme, you've got their metadata associated with it. So it's about building in additional data that can enrich the platform. So here in the back is a graph DB of women's clothing. So this is something what was automatically created, which allowed it to understand the relationship between different clothing and different types of clothing. Obviously, GraphDB is incredibly popular now, but part of it is this big data visualization piece. So I'm working with a company at the moment that look at being able to synthetically generate training data for AI. And this is back to the data engineering aspects. They just don't have enough data. So being able to give you the data coverage that you need to be able to train something without a bias means that it's quite difficult. There's large gaps in the data where it's not got images for a particular type, etc., and therefore you have to be able to create all these relationships by hand, which is incredibly time consuming. I was going to talk a little bit about ethics, but I will skip it due to time constraints. But there was some interesting stuff there on the left-hand side, which has been led by the European Commission. So if anyone's looked at the AI Alliance, if you just Google AI Alliance, the European Commission has a load of stuff around a European AI platform as a service, and also some quite impressive thinking around research on it, on ethics and use of AI. So definitely worth checking out. So I'm going to move into Learns now, which is really going to focus on this AI ops kind of component. So for a long time we've been looking at how do we understand what customer journeys are, and when I was based in Silicon Valley, and one of the challenges we were doing was for the Gartner guys was proving how we could use our APM stack to model user behavior. I know that sounds fairly simple. I know if you've got New Relic or AppDynamics or Dynatrace or any of those platforms, they will give you that information. But we had a bigger challenge in the UK government. We had lots of different activity that was happening, and there was activity which we didn't know what that would look like, as far as new rules for leaving, exiting Brexit. So part of it is we could only model the user behaviour for the current state and not the post-Brexit state, which was fine because we could easily take those user journeys left and model them. And to give you an idea of the tool, so this is, speaking in California, this is a model which was built for Pokemon, which at the time when Pokemon was launched, they said, there's no way that you can try every permutation, we just have to put it out into the wild. And we said, well, actually, we can do this, we can emulate the GPS data, we can push that into the phone, we can do all these different parts and model them out, model the behavior of an end user, and then run it against real devices, which is what we did. And so part of what the demonstration was a few years back to Gartner was this ability to see on the right-hand side the model of what the activity using your APM tool, and then pull that model across to the left-hand side and be able to reproduce that in a kind of a dev kind of sense. So be able to prove hypotheses. If we change this, what will the user behavior look like if we introduce this new change? So this ability to get insight, which we've been all taking this data for a very long time, on the left-hand side, we're taking this insight and then we're adding machine learning onto it to then give you this prediction capability. And I'll talk a little bit about maturity of that, because there is different levels. Again, all kudos back to Gartner on this slide, overlaying that initial diagram that we saw with taking historical data on the left-hand side, real-time streaming data. So this is things like Kafka. So you've got data coming through pretty much all the time, and then on the right-hand side, you've got this anomaly detection, you've got this historical analysis. When I worked at Hitachi, we did predictive crime, which we rolled out into the US and a couple of other locations in Australia. And part of that was predicting where crime would be. All we have is a huge historical data, a data visualization platform, and having machine learning to say, well, this is where you should place your police officers because there's a higher chance that these kind of crimes will happen in these kind of locations. And you can Google it, it's a very interesting piece, and the White House do still continue to use it. But where do you get the data from? And I guess this is the big question, a bit like what we talked about for building those images, is there's a whole stack of systems that typically don't integrate that well. And I know my focus around there today, and their ITOM suite kind of picks some of these components up. And when I spoke to Jerome, as the CTO, his view was, how do I get it so that I can see that one view across the top, so I can get the understanding of the unstructured data into a structured way. So this is things like schema registries or Avro or something that allows you to understand the relationship of data between one system, one ecosystem with another. So, the example which I want to give you is what we were using for the UK government, which was we implemented Dynatrace, which was very impressive. Basically, in fact, we managed to get it into live in 8 weeks, which I don't think I've ever seen any product go into any government system in 8 weeks. But part of that challenge was understanding, well, what data do we really want to look at? What do we want to probe? What data do we want to capture? What do we want to learn? And they just introduced something called Captive, which is an unbreakable pipeline, chaos engineering kind of platform, which again is kind of open platform. It's about what tool you're using. But the idea behind this is it looks at if something happens in production, a bit like you get with a kind of canary rollout, it kind of works out how to back out the problem that was just about to happen from what version of the code, and then kind of tries to self-heal, which is very clever. There was some interesting papers on that piece of work. Back to Gartner again, moving down this ability from descriptive analytics to a diagnosis engine, which is what we end up producing for to do that demo to Gartner. Really on the right-hand side is where it really starts getting interesting. It gets interesting at this kind of predictive analytics, which is where AIOps kind of does, and prescriptive, which is understanding what measures should we take to solve the problem. And that's a big step. I'm not even going to talk about deep learning because it's too difficult. But again, back to Gartner's thing, this overlaps to, well, yes, we've got this operational stance already where we've got the visualization. And one of my friends, Andy at Dynatrace, has been trying to petition to stop people creating their own dashboards, because he says every time he goes into an operational room, he sees these beautiful diagrams that look fantastic. And when he asks them, well, what does that mean? He said, oh, it's just the prettiest visualization that the operational tool had, and my boss walked past and he always thinks it's really impressive. And he was like, well, if you don't understand the context of what that looks like, then how are you going to get to this point where you can do anomaly detection and then identify those problems? So part of it is proactive operations, not reactive. It's understanding the patterns happening. And we've done this for the UK government, where we are expecting nodes to go down, and we've either done the preventative measures of rolling them back or taking them offline, and doing those kind of chaos engineering activities, which people don't seem to be bothered to do, which is the resilience testing. It's unplugging nodes. It's what kind of Netflix and those guys do with the kind of chaos monkey side of things. It's kind of how do you prove systemic failure? What happens when this goes down? And honestly, it's amazing what goes wrong, especially when you're starting to use some of these new technologies. It's incredible. But this is the example of what AIOps is all about. It's this ability to understand that there's a chance that orders will start failing in 18 minutes time. It's understanding that it's going to be, this system is going to fail based on these links of nodes which are all causing a particular pattern which has been seen before, and then it's applying those heuristics, which is again domain based, so it's understanding that actually this could potentially trigger the e-com system to come down, which will then mean orders will reduce, so they can see the cause and effect modelling of each one of those components. So yeah, incredibly important. Now, I'll probably skip this diagram because this was our platform which we put in. But part of where I would like to focus on this diagram is two components. These two components here is a company called Probit, which take any data from any APM, so Dynatrace, AppD, whatever it is, and they model the user behavior and then push that data back in an easy format so you can see every user journey that ever happened, and it visualizes it, but also makes it so you can rerun it. And then this other company down here, which actually use AI as a service to do real-time tuning of instances for things like if you've got a big Docker queue kind of instance, part of it is you can look at what caching you should be applying to your MongoDB, etc., and instead of what you find now with this, this approach of unbreakable pipeline and configurations code, schema registries and stuff like that, is people aren't configuring the optimum performance because it's going from dev, local box to production. We found in the UK government, we found instances of things like Elasticsearch running on a 2 gig container. And we were really sat there and there's so much space free. And we're like, why is this set there? It's just maxing out. But no one seems to be thinking about that tuning opportunity. So these are the quick rules. I know we're probably running out of time a little bit, but the first one is protection. If everyone's read the book Life 3.0, it's a fantastic book around how AI has already evolved past its capabilities. It's actually got to the singularity already, and that we don't know that it's happening. It's a great book to read to give you an idea of some of these kind of capabilities that are out there. In the bottom corner, this is showing Dynatrace fixing the problem before it happens through the life cycle. And then the next one is around perform. So this in the top right corner again is this third-party AI as a service platform, which actually allows you to look at your workload, because part of it is it's not optimizing for speed. It's not. This was the big problem with performance in AI. Was it's not optimizing against AIOps or how fast your disk write or CPU usage. It's actually looking at the workload and then working out what does the workload mean. If it's payment process per second, what actually gives it the best handoff? Is there activities that can be in the background which shouldn't be in the foreground and taking less priority? So real-time AI to tune and optimize those individual components. And you may say, well, what individual components? The other thing which I did for the UK government was this ability to tag our activities. So let's talk about a simple AI endpoint. We would, or user interface. You add in into the caching, or you add into any of the headers the ability to say, this activity is happening, now tell me which components of my ecosystem are actually getting touched, and building a model of that, which of course these APM tools can already do. But what it's able to identify very quickly is that actually 50% of my activity is spent at this one component, and that's the one I should be going in and investigating. So that's incredibly useful because you then understand the model associated with the activity and the workflow. So, and then third, this data aspect. So the diagram on the bottom right is the stack that we're using at one of the AI companies I'm working for. And it's amazing to see what goes wrong with this stack based on the fact that if they hit the APIs, they just go down. It's never getting to Kafka, it's never getting to Neo4j. There's such complex ecosystems that we're building that they didn't think about resilience, they didn't think about scale. they just think about running, getting it conceptually working and failing fast. That they're not really, the enterprise architects are disappearing. So data, and then finally security. So this was Calypso.ai, had some really interesting, you can go onto their website, have a look at the stuff, what they're doing for the US government, and it is fantastic. They've got so many use cases where potentially AI is going to start getting interfered with, malicious kind of damage that's going to happen. And I have to think about how you build that in, so how you container the containers, if you say, or Inception, dreaming in a dream, is how do you protect it so that you can monitor its behaviour and understand whether or not it's being manipulated. So incredibly useful. So I'm going to leave it on this slide, which is kind of the big goals of AI. And what I'm going to suggest is, if anyone has any questions, grab me over a beer, and I will, unpick my brain. So hopefully that has given you a bit of a very fast-paced approach to what AIOps can actually do and add value into your organisation. Thank you. Thank you very much.
Hopefully you will learn that word today. Sitten mä luulen, että kun ollaan tää päivä taputeltu, ja mä uskon, että Jonathan tuossa joko oluen, you said a beer or wine, and then there's a chance to talk about a little bit more. So, jatketaan huomenna 9:00, tai saattaa vähän aikaisemmin, kun täällä on porukkaa, joka näkyy jälkeen, kun 9:00 jatketaan aikataulun mukaisesti, ja siirrytään tuonne afterworkin puolelle.